Okay, so the quiz will cover inverse functions, inverse trig functions, and then application problems, word problems. So what I thought we could do is review the domain restrictions of all of the functions and why we even need domain restrictions. So let's start with sine. Nope. Okay, sine. When we learned about functions in Algebra 2 and inverse functions, remember inverse functions are a mirror of the original function along the line y equals x. Algebraically, you find them by just switching x and y and then solving for y. We know for a function to be a function, it has to pass the vertical line test. So sine of x is in fact a function, because everywhere along sine of x, I can draw a vertical line, and I'm never going to go through the function more than one place. For every x, there's exactly one y. Okay? But there's also a test that we can do to determine if the inverse of a function is a function, and that's the horizontal line test. If you can take, let's just look at parabola that we learned about in Algebra 2, definitely a function, but the inverse of this ends up being that, which is not a function, does not pass the vertical line test. Well, if I had done the horizontal line test on this function, that would have told me that its inverse is not a function, because it goes through the function twice, the horizontal line does. Coming back a little bit? Okay, so same is true with our trig functions. They are functions. However, if I do the horizontal line test, you can see that the inverse of this function will not pass. So when we learned about taking inverse functions of something like a parabola, we did something called restricting the domain. If I just restrict the domain, maybe to, that's not what I was wanting to do. Thank you. To just, come on, just going from the y-axis over, and I just concentrate on that part of the parabola. That does pass the horizontal line test. Okay, so I can take the inverse of this function as long as I restrict the domain of that function to greater than or equal to 0. I could also restrict it to less than or equal to 0. It's up to me, but I can choose. Okay, so the same concept, mathematicians use the same concept to figure out how to take inverse trig functions and still have that be a function. And they decided to restrict the domain of sine from here to here. Because this piece right here, when I draw it, I can do the horizontal line test on this piece of the sine function, and it will pass. Okay? If I went from here to here, it will not. If I went from here to here, it will not. You can see. So mathematicians just decided to pick the easiest domain restriction and just go from negative pi over 2 to pi over 2. Okay? So sine's domain restriction is negative pi over 2 to pi over 2. On the unit circle, that means that we're only interested in values in that, the first and fourth quadrant. Okay? If I overlay cosine onto this, maybe down here, something like that. It does not pass, if I do one period, it will not pass the horizontal line test. But if I restrict it from here to here, 0 to pi, that little piece will pass the horizontal line test. Okay, so cosine, the domain restriction, that's just the universal domain restriction that mathematicians decided on, is 0 to pi. Now, we could have picked from pi to 2 pi, or 2 pi to 3 pi, or 3 pi to 4 pi. All those domain restrictions would work, but trying to keep them close to the origin, 0 to pi is kind of the universal domain restriction for cosine. Okay, tangent, cotangent, same kind of idea. Tangent these are your asymptotes, and tangent looks like that. So its domain restriction is actually just that graph around the origin, from negative pi over 2 to pi over 2. Okay, cotangent actually has asymptotes at 0 and pi. So its domain restriction is from 0 to pi, just between those two asymptotes. Okay? Secant and cosecant are the same as sine and cosine. Secant goes with cosine, sine goes with cosecant. They share the same domain restrictions. Okay? Am I right about that? I have to think now that I say that. Come on, go down. Secant, this is the cosine graph, and my secant then is like this, right? So actually secant goes from negative pi over 2 to pi over 2. Cosecant goes from 0 to pi. So secant and tangent are the same. Cosecant and cotangent are the same. That makes sense? Actually, I'm wrong again. Because I can't make this for secant, I can't make it from negative pi over 2 to pi over 2 because that won't pass. Right? So it's got to be, how do I do this? It's going to go down here. So I'm going to go half. So it's going to be this piece and this piece. So it is the same as cosine. Sorry. Secant and cosine are the same. Cosecant and sine are the same. But these really are the ones that you're going to see over and over are really the sine, cosine, tangent, cotangent. You don't see a lot of inverse with secant and cosecant, but you can. So just, I mean, if you can't remember all of them, just do quick sketches like I did and see where it could be restricted so that you can pass the horizontal line test. Does that make sense? Okay. Where these come in are with when we do arctangent or inverse sine. When you have the sine of the inverse sine of something, work from the inside out. The inverse sine just means what angle is sine equal to 1/2. That's what the inverse sine means. What angle is sine equal to 1/2? Because what goes in here, this whole thing, needs to be an angle because it's sine of an angle. Right? So what angle is sine equal to 1/2? Well, that angle is 30 degrees, or pi over 6. Right? So then we put pi over 6 in here, maybe. I don't know why my board's deciding to be so uncooperative today. But if I put pi over 6 inside, then it's just sine of pi over 6, right? And sine of pi over 6 is 1/2. So one of the rules that we learned is come on. Sine of inverse sine of x is just equal to x. Okay, cosine of inverse cosine is equal to, or cosine x is equal to x. Tangent of inverse tangent of x is equal to x. Where it can be tricky, though, is what if I said, I want to do it this way, sine of no, I want to go this way. Sine inverse, no, I'm going to do it that way. If we use this rule and the other is the inverse sine of sine x is equal to x, if we use that here, we can't say this is equal to 4 pi over 3 because that's not in the domain of inverse sine. You know what I mean? 4 pi over 3 is past 180. It should go this way. Past 180. And the domain of the inverse sine is 0 to pi. Can't be anything bigger than that. Okay? So this is not equal to 4 pi over 3. So what I do is I figure out what sine of 4 pi over 3 is. Well, 4 pi over 3 is this angle 30 degrees, right? Everybody with me on that? Or is it 60? It's 60, isn't it? Pi over 3. Sine, then, is the square root of 3 over 2, and it's negative. Okay? So the sine of 4 pi over 3 is negative square root of 3 over 2. Well, where in the actual domain that's allowed on the arc sine is sine equal to negative square root of 3 over 2? Well, it's allowed from negative pi over 2 to pi over 2, first and fourth quadrant, right? So it's this angle where it's equal to negative square root of 3 over 2, right? Which is 5 pi over 6. No. 5 pi over, let me get this right. 3 pi over 3, 6 pi over 3, 5 pi over 3, right? So this is equal to, if I could get it to work, 5 pi over 3. Okay, because it's equivalent. At 4 pi over 3 and 5 pi over 3, sine is equal to negative square root of 3 over 2. But the arc sine can never be outside of first and fourth quadrant. So I have to find the same value of theta that would give me sine to be negative square root of 3 over 2 in the fourth quadrant, which is 5 pi over 3. Okay, so you have to be a little careful when you see, you just have to think a little bit about what the domain of sine and cosine is, and make sure that your answers fall in that domain. Okay. The other kinds of problems that we saw in this section were, I'll just do one of these. Not right. Problems like this. Evaluate, let's do cosine of and remember, when you see arc in front of it, it means the same thing. Arc sine is sine to the negative 1. Okay, so it wants to evaluate what this is. Well, should my answer be an angle or a fraction? Fraction. Because this is an angle, this whole thing. When I take cosine of that angle, I'm going to have some sort of ratio. It's not going to be an angle. this is an angle. Okay? So what I'm going to do is just draw my triangle. It's arc sine. So where is arc sine possible? What quadrants? 1 and 4, because it's between negative pi over 2 and pi over 2. Okay? And sine is negative if, of those two choice quadrants, 1 and 4, sine's negative in 4. Okay, so here's theta that I don't know, and I'm going to call this negative 7, and this is square root of 130. So I need to find this value, right? Because to find, this is my theta, and I'm going to take cosine of that theta, and I'm going to get a ratio. So I'm going to take 130 and subtract 49 to get what? 81. So this is 9, just the inverse Pythagorean theorem. So cosine of arc sine of negative 7 over the square root of 130 is 9 over the square root of 130. Right? And it's positive because it's in the fourth quadrant. Okay, let's do another one. If I can get the right quiz. Tangent of cosine negative 1. Let's make it negative. So what quadrant is this in? Now, it's possible, inverse cosine or arc cosine is possible in quadrants 1 and 2, from 0 to pi. Okay, and if it's negative, it must be in quadrant 2. Okay, and I'm just going to follow what they say, negative square root of 3 over 2, which means this must be 1. And now that's my angle theta. So tangent of theta is 1 over negative square root of 3, or negative square root of 3 over 3. Follow the process. Okay. So, because it's restricted from 0 to pi. What about, let's do sine. Where's tangent restricted? Yeah, negative pi over 2 to pi over 2. Because that's where the asymptotes are. Where is it negative then? 4. And I'm going to draw my triangle then in the fourth quadrant. And negative square root of 3 over 1. Right, is tangent. Opposite over adjacent. So that means that this is 2. And now I'm going to take sine of that angle, which is negative square root of 3 over 2. So the first 3, 4, 5 are like that. This one just says what angle is this true for? What angle is this? In radians. Maybe. I don't know what the point of having a board is anymore. So what quadrant is cosine negative? Forget about the inverse cosine. There's two quadrants, it's negative. What are they? No, it's positive in 1. Where is x negative? 2 and 3, right? But arc cosine or inverse cosine is restricted to 1 and 2 only. So it must be talking about the second quadrant. And in the second quadrant, this is a 45-degree angle, right? Which is 3 pi over 4. Right? 45-degree angles are always pi over 4 and multiples of that. 180 is 4 pi over 4, and it's just 1 pi over 4 less, so that makes it 3 pi over 4. So the answer here would have been 3 pi over 4. Okay. There's two possibilities. Cosine's also negative down here, but you'd have to understand the domain restriction to know it has to be the second quadrant. The sixth question on this says, a tree casts a shadow that's x feet long. What's the angle of elevation? Pretty easy. Everybody okay with that kind of question? That's all it is. And then the last one has to do with a spring and being able to write the equation of a spring. So let's talk about how we might do that. I'm not going to use the same numbers. This is rest. And what this one says is a mass is suspended from a spring and is pulled down a distance of, and I'll make one up, 4 feet. So we have this mass, and this distance is 4 feet. The mass is released at time equals 0 and allowed to oscillate. If the mass returns to this position after 5 seconds, find an equation that describes its motion. Okay, so what's the period? 5, right? How do I make that a coefficient? 2 pi over 5, because 2 pi is the normal period of sine cosine. And so if 5 is the period, I take 2 pi over the period to get that coefficient that goes in front, right? So anytime it starts from rest at some place other than 0, so here, if it started at 0, at rest, and it went up or down, whatever it did, sine is your best bet, because sine starts at 0. You could also model it using cosine, but then you're going to have a translation, a phase shift, because cosine never starts at 0. So you're going to have to figure out what that is. So it's a lot easier to model using sine when it starts at 0 and using cosine when it starts at something other than 0. So when I look at this problem, it actually starts below at 2, right? Maybe. I don't know why it chooses to do this. It starts, let's call this 2. When time is 0, the first point is 2. Then it comes up, reaches a peak, and comes back down 5 seconds later. Something like that. This is negative 2. So it does a full rotation. Okay, thinking of cosine, is that kind of what cosine looks like? Except what? It's flipped, right? Normally it starts here, goes down and comes up. Now it starts here and goes up and comes down. Okay, so I'm going to use negative cosine. Instead of starting at, or this was supposed to be at 4, right? Not 2. Okay, thank you. I'm going to start at -4. So normally I start at 1. So what's going to go in front? The amplitude. And there's no phase shift. Does that make sense? Okay. This is why trig is so powerful, is there's so many types of problems in the real world that can be modeled using trig functions. And if you can figure out a model for something, it allows you to predict future behavior if you know what's going on in the parameters that you have. You know, so there really are a lot of real world applications with trig functions. This is an example of one. Physics, they are used a lot. Okay, so those are the 7 questions that'll be on the quiz. There'll be a spring one like this. There'll be a tree shadow one, which should be a geometry kind of question. And then the other 5 are going to be, you're just testing your knowledge of inverse functions. Questions? Okay, shouldn't be too bad. And then tomorrow is Thursday, so Friday I'll probably give you the review for the chapter and let you have class time to work on that on Friday. Monday, go through it. Tuesday next week we'll have the test. Okay.